Hello everyone, and thank you for being here. My name is Abdur Rahman, and today I'll be presenting our paper Detecting Manipulation in Ukrainian Telegram, a transformer-based approach to technique classification and span identification, co-authored with MD Ashiqur Rahman. This work was part of the UNLP 2025 shared task. Here are the content we will cover today. The ongoing war in Ukraine is not just a physical conflict, it is also an informational war. Social media platforms, especially Telegram, have become a major battleground for this. Telegram is often used to spread misleading information, pro-Russian narrative, and outright falsehood to influence the public opinion. Being able to automatically detect this subtle manipulation technique is very urgent security concern. It helps us to find disinformation and protect the integrity of online information. This task presents several key challenges. First, the nuance of manipulation. We are not just looking for fake news. We are trying to find the subtle tactics like emotionally loaded language, whataboutism, appeal to fear, which are very hard for computer to tell apart. Second, the dual task complexity. We need to solve two problems at once. First, classify what the technique is being used, and second, identify exactly where it is in the text. The third, the linguistic richness. The data is in Ukrainian and Russian, which are complex Slavic language. This makes it very difficult for model to understand the context and the word structure correctly. Finally, we face a data imbalance. Some manipulative tricks are very common in dataset, while others are very rare. This makes it very hard to train a model that is good at detecting everything. So what did we contribute? First, we tested a wide variety of models from machine learning to complex transformer models to see what works the best. Our fine-tuned transformer model achieved a competitive result in the UNLP 2025 shared task. We secured third place in technique classification and second place in span identification. And most importantly, we provided a detailed analysis of our model's error. This gives us a valuable insight into how this model performs on Slavic language and the specific challenges of this shared task. Our model was based on the official UNLP shared task. The dataset consists of Ukrainian and Russian telegram posts provided by taxi.org.ua. There are two main tasks. Task 1, technique classification, where the goal was to assign one or more from the 10 manipulation level to a post. This was measured using the macro F1 score. Task 2, span identification, where the goal was to pinpoint the exact start and end of a manipulative text. This was measured with a span F1 score. The table shows that the size of the dataset, which include over 3000 training examples. This slide shows our overall processes. We have two separated pipelines for two separated tasks, but they follow a similar structure. We start with the data, preprocess it, then extract the feature. We experiment with three types of model. Simple ML model like linear regression, deep learning model like LSTM or GRU, and advanced transformer model like XML Roberto. For classification, the model output a set of labels. For span identification, the model output exact start and end point of a manipulative text. So now for the result, this table shows the performance of different models on both tasks. The key takeaway is that transformer models significantly outperform both ML and DL baseline. As you can see from the bolded score, our base model XML Roberto Large achieved highest F1 score, nearly 0.45 for technique classification and 0.60 for span identification. This clearly shows that large pre-trained multilingual model are extremely effective for understanding the complex and nuances language in this task. So what did our best model make mistakes? This first confusion matrix is for classification tasks. The model did well on common tactics like loaded language, but it struggles with rare ones uh, like like Strawman and Bandwagon. The off diagonal number are also shows that it often got confused between similar techniques like FART and appeal to fair. The second matrix is for span identification tasks. The high number of false positives shows that model tends to overpredict the span boundaries. This means it often tag a few extra natural words that are near the manipulative text. Here are some of the specific examples of those errors. In the first table for classification, we can see that the model correctly identified loaded language, but it also added extra incorrect label like whataboutism. This shows that it struggles with technique ambiguity. In the second table for span identification, the ground truth had two separated manipulative phrases. Our model made a mistake and merged them into one long span. This shows it frequently makes boundary errors. Our work has some few limitations. First, the model reliability is low for very rare techniques simply because there isn't training data for them. Second, struggle to precisely identify the start and end point of a complex Slavic language, which causes the boundary error we saw. Third, technique with similar rhetorical goals like loaded language or and appeal to fear are often confused by the models. And finally, our model was tested on Telegram data. We don't know how well it will perform on other platform or propaganda styles. Based on this limitation, we have several plans for future work. First, we will use technique like synthetic data augmentation to improve performance on rare manipulative classes. We also plan to uh, implement boundary-aware models that are specifically designed to make precise span predictions. To help the model distinguish between similar tactics, we will explore using constructive learning. And finally, we want to develop a custom tokenizer and embedding to better handle the real-world messiness of code mixing and different dialects. To conclude that we present a robust system for detecting manipulation that achieve top 3 performance in the UNLP 2025 shared task. We demonstrate that large transformer models, especially our XML Roberta large, are highly effective for this domain. Our analysis highlight that the key remaining challenges are distinguishing fine-grained techniques and precisely identifying span boundaries, which are important areas for future research. This work is significantly step toward creating automated tools to help fighting information warfare in critical real-life contexts. Here are the references. Thank you very much for your time and attention. If you have any question, you can ask.